We're trying to give you time to digest the material. We're trying to do what I just spoke of. When you go home, look at your quizzes. When you go home, look at your homework and see what kind of questions gave you a little bit of a hard time. Okay, so let's take a look at number one on the do it. Find the vertex of the graphs of the following quadratic equations. Now, before we start answering these questions, I want to just take a moment to remind you of the general form, the vertex form. Guys, in the game. The vertex form that we talked about yesterday, and it was this. Okay? Y equals A times x minus h squared plus k. We're going to talk about the A a little bit in a couple of moments, but for now, I want to remind you, what does H stand for again? Andre?
Horizontal.
Horizontal shift. Very good. Horizontal shift. And the thing you have to remember, there was something I put in parentheses. What do you have to remember about it? It's always what? Come on, everybody. It's what? Minor?
Opposite.
It's always opposite. Very good. All right, so if it's positive in the parentheses, it's to the negative side. If it's negative in the parentheses, the positive side. And K is, and I'm going to spell this wrong on purpose, vertical shift. Okay? K slides it up and down. K does not get reversed. Only the H gets reversed. Now the A affects the thickness of the parabola. If A is greater than 1, it's a very skinny parabola. If A is less than 1, it's a very wide parabola. So in this particular case, it wants to find the vertex of the following quadratic equations. What is the vertex of this equation? What's the x-coordinate of the vertex? Everybody?
5.
5. And what's the y-coordinate?
3.5.
3.5. Very good. This parabola will be skinnier than a regular parabola because of the 2 in front. Okay? Basically, it means every y gets twice as big, or it gets as big twice as fast. Next one. This one. What is the coordinates of the vertex? -1, -8. And this parabola will be the normal width, but it'll be upside down. Why do I know that this parabola will be upside down? Because it's a negative in front. Okay? Any questions about that? Okay. This one says use a leading coefficient other than 1. Here is the vertex. So y equals, give me an equation.
3.
Someone who hasn't helped me yet. Parker, give me an equation here. Y equals? All right. Extremely important, Parker, that you understand this. The H and the K are the vertical shift. So notice that before it was 5 here, 5 here. 3.5 here, 3.5 here. It's actually -5 and it becomes +5. So an example of this would be, I can put any number in front for A, it doesn't matter, 3 times x minus 100 squared plus 200. It is extremely important that you understand why this says x minus 100 and why this says plus 200 at the end. If you don't get it, you are missing the entire point of yesterday's lesson. Yes?
Do you have to put a number in front of it?
Well, only because it says use a leading coefficient other than 1. If it didn't say that specifically, no, absolutely not. Okay?
Gotcha.
Next one. Y equals. Somebody else help me out here. Andre's helping me. Wyatt's helped me. I want somebody who hasn't yet. Lily?
2
Yep.
parentheses x minus 3/4
Plus 3/4.
plus 3/4 square
Yep.
plus 6.
Minus 6.
Oh,
You're
I don't
reversing
see that.
opposite. Remember, listen. The horizontal is the opposite. The vertical is not. So you're reversing the other way around. You don't want to do that. Yes?
You can just put any number you want.
Yeah, when it says use a leading coefficient other than 1, you can use any number you want. Okay? In reality, there are times where you might need to use a number, figure out a number more specific than 1. But for now, they just said use any coefficient other than 1. You could have put a half there. Okay? This one on top, like let's just use a half here for 1 minute, just to show you the difference. If this is the normal graph, if this is the normal width of a parabola, and it wouldn't be necessarily there, but 3 times it would be this, it would be really skinny, and a half times it would be really wide. Okay? All right, so now let's go to the next section of today's work. Ready? Oh, here we go. Using vocabulary from this lesson, describe the relationship between these two quadratic equations. y equals x squared plus 1, and y equals negative 2x squared plus 1. There's something they share in common. What do they share in common? What's that, Savannah? Okay, and the plus 1 is known as? The k, which is the vertical shift. Okay, good. What else do they share in common? Wyatt?
X squared.
The x squared. So what's the horizontal shift in this one?
Me?
Everybody. The horizontal shift, what is it? 0. Isn't this as if it says x minus 0 squared? Right, are you with me on that? So what is the vertex of both of those graphs going to be? It's the same vertex. What is it going to be? 0, comma 1. Very good. So we've used vertical shift from yesterday. We've used horizontal shift from yesterday. We've realized that in comparing the two parabolas, they have the same exact vertex, which is 0, 1. But there's some things that are different than these parabolas. What's different? Andre, what's one difference?
Oh, they have different leading coefficients.
So how does that affect the graphs?
How skinny or wide is it?
Okay, which one's going to be skinnier?
The x squared plus 1.
No.
No, never mind.
Lily?
The 2x squared plus 1,
Now, why is it going to be skinnier?
because it has a negative 2 in, like.
It has a number bigger than 1 in front. The bigger the number, the skinnier it is.
But it's negative.
What does the negative do to a graph?
Transfer
Flips it upside down. Okay? So the bottom graph, y equals negative 2x squared plus 1, that's going to be a frowning graph. Remember the negative means frown? The top graph will be a positive graph. So if you wanted to, they have the same vertex. And by the way, you could always put this in the calculator and see this. If the top one looks like this, the bottom one is going to look like this. It's going to be skinnier, and it's going to be negative. Okay? In both cases, they share the same vertex of 0, 1. Okay? Any questions? All right, next. Number 4. A high school baseball player throws a ball straight up into the air for his math class. The math class was able to determine the relationship between the height of the ball and the time since it was thrown could be modeled by blah, blah, blah. Where t represents time, the ball was thrown, blah, blah, blah. What is the domain of the function in this context? Okay, so let's talk about the domain. What is the smallest possible value for t? Because domain means the set of all inputs. What does domain mean?
Set of all inputs.
What does domain mean?
Set of all inputs.
Set of all inputs. So, if I take a look at the inputs on this problem, the domain is set of all inputs. We did this earlier in the year. What's the smallest possible input for a situation where it's time? What's the smallest possible input? Minor?
16.
No, the input is t. What values of t could I use? The smallest possible value for t. Mia. What's the smallest possible time that you could input into a function about throwing a ball? No, you can get even smaller than 1. What else have we got? Go ahead. 0. The smallest possible value for t is 0. At time t, we haven't quite thrown the ball yet. And then the time could go. Now, in this problem, I need to figure out how long until the ball touches the ground. So can you guys, one of you is on your calculator, or all of you is on your calculator, type in negative 16t squared plus 96t plus 6 and see how long it takes to get back down to the x-axis, that is to say, back down to where it hits the ground. Hopefully it goes right through a perfectly straight point.
This is what I got. Just goes straight up and down.
No, it doesn't. It's, what it is it's the section of the graph that you're seeing. 1, 2, 3. Good, I thought it was 6. I'm pretty sure it's 6. Let me go to the table.
Broke mine.
I got that one.
No, 6 is 6. Ah, I see, it's actually, see, let me do this on the board using my, just to show you so everybody can see. Okay? This is extremely important. Because when you first look at the graph, it looks like it goes through 6 seconds, but it's actually almost 6 seconds. It's not exactly 6 seconds. So sometimes you need other functions in this particular calculator, Okay, so here we go, loading menus, toolbar, blah, blah, blah. Come on, yeah, I didn't, this whole did. Val. This is just mind-boggling that it slows down so much. Do, 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 do. There we go, look at that, very nice, okay. So, let's go to y equals. I'm going to clear, and I'm going to clear. All right, so it was negative 16t squared? Negative 16t squared plus 96t? Minus 6 or plus 6?
Plus 6.
Plus 6. And then I hit graph. And first off, why it said that it's a straight line. It's not a straight line. It's just a part of the parabola that looks almost straight, okay? Let's just do a little playing with the window here to practice playing with the window. The x minimum, I'm going to go to -1. The x maximum, I don't need to go to 10. I'm going to go to 7. And then the x scale will be by 1s. The y minimum, I'm going to go to -1. And the y maximum, obviously it's a lot higher than 10. So I'm going to go to 200. Just, hopefully it fits in really nice. And then the y scale, I'll go by 20s. I'll go by 10s. And then let's go graph. Let's see how it looks. There we go. I get a nice picture of this. When I first looked at this graph, I thought, oh, gee, probably goes right through 6. But the truth of the matter is, it does not go exactly through 6, okay? Now, I knew that because I went to table. I went second, table. And when I got down to 6, let me scroll through. If it truly took 6 seconds, this would be at 0, right here. Does that make sense? But it's actually at a height of 6. So let's go back to the graph. Come on, graph. Now, do you remember how we have that zeros function? The zeros function tells me when it crosses the x-axis. So, what I'm going to do is go to calculate, which is second calc. And the second one is zeros, so I'll hit 2. Now, remember it says left bound? We talked about this the other day. You just have to be on the left side of this. I could do it right where it is. But I wanted to get a little bit closer. All right, so I have to touch this pretty soon. Come on. It's something like if you hit it 3 times in a row, it keeps going. Ready? I gotta wait for it to get close. Stop. Stop! See, now here's the problem. It's such a pain in the butt because, now watch, it's gonna move. See, it's like an evil. It's possessed. See, now I stop and it doesn't move. So now I'm going too slow. Get close. All right, it doesn't matter where on the left side you are. So to me, that's close enough. So I'm going to hit enter. Then it says right bound. So now I got to move it to the right side.
We're already on the
No, I want the 0. The 0's down here. I don't want the maximum. If I was doing maximum, I would have been there.
Oh, the left side of the 0.
Right, the left side of the 0. Now, here we go. Good. So I'm going to hit enter. Guess is always the same. I hit enter. And it says 6.0618622. For the purposes of this problem, I'll allow you to round it to the nearest hundredth. which is 6.06. So, when I go back to inputting my domain, let me go to here. When I go back to inputting my domain, I'm going to go to 6.06. I think that's what it was. Okay? So anything between 0 seconds and 6.0 seconds, the ball is going to be up in the air for. What does the range represent? Now, range is not the x value. What value is the range? The y value. So how do we use, I can eliminate this now. Oh, actually, I'll go to this. Ready? The range, set of all outputs, and it's the y values. So obviously, I could be 0 height, and I guess we're calling it h of t. And now I need to know what my maximum height is. So I go back to my graph. And this time, I'm going to calculate again, second calc. And this time, I'm going to go to maximum. And notice how it says left bound. But my little blinking bug is over here. So I need to go to the right side now. I'm not quite there yet.
On our calculator, for some reason, I can get it to go straight across the graph.
Really? Yeah, I don't know why I can't, but I can. If you do that, you have to make sure the little bug stays on the graph itself. If you go straight across and it ends up off the graph, you can't do it. It's got to be on the graph. All right, I'm almost there. I want to be on the left side. That's the left side. Good. Enter. Then it says right bound. I just move it a few more. Good. Enter. Guess. Enter. Maximum. Now it comes out to a nice whole number. The y is 150. So now I'll shrink this down. I'll go to this. And my maximum height is 150. Okay? So at time 6.06 seconds, I'm back to a height of 0. At height of 150, I'm at the max of my height. So if I graphed it, this vertex would be the middle of these two. Well, not necessarily the middle. It would be somewhere around there, probably 3 seconds, 150. Okay? Now, let's get going on the next part of this.
Are we gonna have a test on this?
This will be included, you know, we'll graph parabolas and ask you questions like what's the domain, what's the range, what's the maximum height, how long does it take for the ball to get back to the ground. At what height does the ball get thrown from? That should be very simple for everybody.
0.
No. What's the y-intercept on this function, guys?
6.
6. So it gets thrown from a height of 6. After about, oh no, it says exactly, after how many seconds does the ball hit the ground? We just did that a minute ago. 6.06, good. What is the maximum height that the ball reaches while in the air?
50.
150, right? And then it says, how long does it take for it to reach its maximum height? Would you please look at your table? Is it 3 exact? What's the table? What's the value associated with 3? I think it might be exactly 150. It is 150. Good. So it would be exactly 3 seconds. The reason it's off a little bit at 6.06 and the 3 isn't exactly in the middle, Andre, is because it went from a height of 6 feet. If it had gone from a height of 0, then it would be 3.03. Does that make sense? Okay. Guys, any questions about that? Listen, we are digesting this material. It is extremely important that you just do the problem and chew on it. Think about it, okay? So if you didn't understand any of the parts of that, this is why I told you the story about college. What I would have done if they had this question in college, my classmates go into the class, I would have sat on the kitchen table, I would have done all the problems without their help. If I'd have gotten them right, I wouldn't have bothered thinking about it anymore, I'd go to bed. But if they didn't get it right, I would sit down and go, how are they coming up with that answer? Why is it 6.06 seconds until it hits the ground instead of 6 seconds? Oh wait, if I look at the table, at 6 seconds, it says it's still 6 feet above the ground. I need to know when it's exactly at 0 feet for when it hits the ground. So all of these sorts of questions can go through your mind and you rehash them. Obviously, if you need to go over it again, you could ask me in a minute, or you could ask me an extra help. Sarah, did you have a question?
It wasn't about that.
Okay. you guys can start your homework. If you have any questions from last night's homework and you still need to understand, you can bring that up to me as well. Okay,
Did you still talk to those people?
the people from college?
Yeah.
1, 2, 3. 1, 2, 3, 4. I want to say 1, 2, 3.